Problem 4 on the super sheet. Alright, you're given a bug walking along the x-axis and you're given the velocity. Use a table to answer these questions. Assume the velocity is continuous and differential. Alright, find the average acceleration over the interval. Well, this is what's confusing, but you're given velocity. So velocity and the relationship between velocity and acceleration is the derivative, or acceleration is the slope of the velocity. So when it says find the average acceleration, that's the same thing saying find the average slope. So then you just do, so the average slope would be v of 15 minus v of 0 over 15 minus 0. So v of 15 is 8 minus 2 over 15. So 6 over 15, which is what, 2/5? Alright? And then it says, using correct units, explain the meaningless answer in the context of the problem. Alright, so the average acceleration of the bug between time t equals 0 to 15 is 0.4, and what is it, feet per second squared. Or you can say it's 0.4 feet per second per second. Right, that's what a second squared would be. But it's basically, the acceleration is 0.4 feet per second per second. All right. Approximate the acceleration of the bug at t equals 4. So here, you don't have t equals 4, so the approximation would be the slope between 3 and 5. So the acceleration around 4 would be v of 5 minus v of 3 over negative 5 minus 3. So v of 5 is negative 3. V of 3 is 6. So negative 8. So that's, sorry, not negative 8. 5 minus 3 is 2. So that's going to be negative 9 over 2, or negative 4.5. So the approximate acceleration is, in other words, he's slowing down. So it's negative 4.5 feet per second squared. All right, C, how many times can we guarantee that the bug is at rest over the interval from 0 to 15? Well, so a rest means v of t is equal to 0. That's what a rest would mean. So is it ever equal to 0? Well, looking at this, because it is negative 3, it has to equal 0 between these two and these two. So yes, how many times can we guarantee? Explain your reasoning using proper mathematics. All right. So the bug is at rest at least twice between, at least twice. Once between t equals 3 and 5, and once between t equals 5 and 8. Since v of t is continuous and differentiable, we can apply IVT, the intermediate value theorem, because the sign changes. Because the sign changes on those intervals. I worded it a little differently in the answer key. And I think maybe I did worded better on the answer key. Okay. All right. All right. This is part D. Is there a time when a sub t equals 0 on the interval 0 to 5? Justify your reasoning using proper mathematics. Is there a time? Well, yes. All right. So what are we doing here? So we want to say, when is the slope ever equal to 0 on this interval, 0 to 5? That's also something to pay attention to. They are talking about only this subinterval, 0 to 5. All right. So looking at this, it goes up and it comes back down. Right. When something goes up and it comes down, the slope must be equal to 0. Keep in mind, it does say that it was continuous and differentiable. Right. Now we know that it has to equal 0, but now we have to justify it. This is where it gets complicated, justifying it. Right. So probably when you just look at the data, right, from at time t equals 0, it's at 2 feet per second. At t equals 5, it's negative 3 feet per second. So at some point it had to hit 0. I'm sorry, the acceleration had to be 0 because you were going downwards, or the acceleration was going downwards. Okay, so how would you do that? Well, the best thing to do is to use mean value theorem or Rolex theorem. To me, Rolex theorem is the easiest one here because between t equals 3 and t equals 5, the velocity had to be 2 at some point, right? So if we can show that v of 2 is 0 and there's some time t that's equal to 2, and by Rolex theorem, since the beginning one is equal to 2 and somewhere in here is equal to 2, then there had to be, Rolex theorem says there must be some value t in between 0 and whatever that other value is, that the slope is 0. That's what Rolex theorem says, that it has to be 0. Right? Rolex theorem, remember, Rolex theorem says something like this. If I have some function a, some function f, such that f of a equals f of b, and f and b are start again. Rolex theorem says, if I have f of a equals f of b, and f is differentiable and continuous, then there must be an f prime of c equals 0 on the interval a to b. All right, that's what that says. Rolex theorem says that. So there must be some part where it's equal to 0. So I wouldn't use the mean value theorem because it's a little more difficult to use in this case. Okay? So Rolex theorem is the easier one because it guarantees that the slope is 0. And in this example, acceleration is the slope. Right? Remember, acceleration is the slope of velocity. All right. So yes. So there is it. So I'm using. I'm going to use Rolex theorem to get here, but I'm going to need to use the intermediate value theorem to get some t such that v of t equals 2. Remember, I want 2. Okay? You can't get 6 and you can't get negative 3, so 2 is the obvious choice. Right? I can't get another 6, I can't get another negative 3, but I can get a 2 because 2 is between 6 and negative 3. Alright, so here we go. So yes. So how am I answering this? Yes, there is a time. So my first thing is I'm going to set up. First, I'm just answering the question. Is there a time? Yes, there is a time. There is a time when a sub t equals 0. All right. On the interval, I don't know why we said it. Let's say on 0 to 5. Okay. You just say on 0 to 5. All right. Because, or I'm going to say since v of t is continuous, all right, and differentiable, by IVT, right? So we're going to use the intermediate value theorem to establish v of t equals 2 on this interval here. By IVT, there's a time, and we're just going to make up a variable here, t equals c, such that v of c equals 2 between t equals 3 and t equals 5, because v of 3 equals 6 and v of 5 equals negative 3. Okay, so that's enough to say there is some value c. Now, so we have v of 0 equals 2 and v of c equals 2. And since v, so probably you don't need to say it again, but I'm saying it again for emphasis, right, is continuous and differentiable then by Role's theorem. A of t equals 0 sometime between t equals 0 and t equals c, which is less than 5. Okay? Or you could just say t equals. Alright, so yeah, that was a toughie because you had to use 2 theorems. Okay, and there might be a better way. We'll ask somebody else. Alright. E, using correct units explaining the meaning of that. Alright. So remember by net change theorem, right? Remember we had net change theorem. So this is the net change, or, well, is the net change in distance, right? This is velocity, but when you integrate it, that's distance. The bug traveled during that time. Traveled between time t equals 0 and t equals 15. That's it. All right? Okay.